Hi everyone, today I'm gonna show you how to set up a HEC HMS model from the beginning. So if you have your basin boundary and other informations like precipitation and the necessary information for setting up this model, so you can set up this model. So this is our basin boundary. So at the end of this tutorial I'm going to give you the information. You can find the folder in the description of this video. You will be able to download this information for setting up your model if you want, and you can practice this model, and in the future video we'll show how to prepare this basin boundary from DEM data using ArcGIS software. So let's start. At first I'm going to click on the HEC HMS shortcut from the desktop. So you can click on it. It will open the window. You are already familiar with this if you have already installed your HEC HMS software on your computer, right? So at first you have to create your project. So click on the file and then you can click on new, or you can click here. It is also the same, right? So I'm clicking here and it is asking for the directory or location where you want to save your model. So I'm just clicking here and I'm going to the directory that I want. It is here, right? HEC HMS, and then I'm selecting this folder. You can give you the name of the project folder. So it is tutorial 3, right? And you have to select your model units. So we have a 2 unit metric, which is SI unit, where meter is the unit of length and meter cube per second is the flow rate. So I'm not gonna select this one, since in USA it is US customary unit. So you can select this one, US customary, where the flow rate is in CFS. So I'm creating my projects. Yeah, this project is here. It is tutorial 3. So if you click on this, there is nothing. That means you have to specify your model boundary. So from the tutorial 2, we need 3 types of components, right? So the first one is the basin model. So see, if I click on this component, what I'll see, I'm seeing here the basin model manager, the metrologic model manager, control specification. For running this model we need these 3. Since this is not a graded model, that's why I'm not gonna select the grid region manager, right? So first click on this basin model manager. It is asking that you can create new. Click on new, so you can rename it or you can just give the name as it is. So I'm not changing the name, just create it and then close it. So see, your basin model is here, basin model, but it is empty. There is no boundary of the model. So I'm gonna give you this boundary because I already have created this boundary using GIS here. So it is there. If you click on this, and then you can copy all the chef files, Control C, and then find the location where you have created your model, right? So it is there. It is tutorial 3, and then see maps. You can paste here. It is there. Now click on view and then map layers. So you'll see this window and then click add and then navigate to this folder map where you have just copied all the shape files, HMS and the tutorial 3 and then the maps. See, we have 4 points. We have stream, we have sub watershed, and we have watershed as well. So I'm just selecting one by one. So it is there. I can add the sub watershed, it is there. I can also add the streams, it is right there. I can also add the 4 point, means when I created this sub watershed, I just created the outlet of is sub watershed. So there are 1, 2, 3, 4, 5 sub watershed, and each sub watershed has 5 different outlets, right? So this is our model boundary. Since this is basin model, we have to specify our basin, and this is our 5 sub basin. So see from the shapefile what we are observing here. So this is the stream link, this is upstream and this is the downstream. So water of this sub basin will be accumulated here and then it will flow through this channel or stream, and it will be accumulated here and then it will be flowing through this channel at the outlet, and same thing will happen for this sub basin. Water will be accumulated here at the outlet and then it will just flow through this stream and it will be accumulated here and then it will also flow through this channel and it will be combined with this flow and then it will be there at the outlet. So let's start. I can just start with creating the sub basin tool. So here you can see, if you click here, it is sub basin creation tool, it is a reach creation tool, and it is a reservoir creation tool, it is a junction creation tool, it is diversion creation tool, it is source creation tool, and finally you have sink creation tool. So all of the tool may not be useful here. Since we have 5 sub basin, I can click on sub basin creation tool. If you click here and then if you click here, so sub basin 1, you can rename it or you can just create. So it is sub basin 1. So I'm creating this as sub basin 2, and this is sub basin 3, this is sub basin 4, and this is sub basin 5, right? So what we have to do next, we have to connect with reach or stream. So now click on reach creation tool. So I'm clicking here. So reach is connected from the outlet of sub basin 1 to the outlet of sub basin 2, right? This is reach 1, and another reach from the outlet of sub basin 3 to the outlet of sub basin 4. This is reach 2, and then sub basin 5, right? So I'm just drawing another reach from the outlet of sub basin 2 to the outlet, and see from the outlet of sub basin 4 to the outlet of the whole basin. So it is the same. It may combine here or it may combine at the outlet. It is the same. It will be added the 2 flows there and it will produce time series. So we'll see at the end of our model, we'll see the simulation result. So now we have already assigned our sub basin and we have already assigned our reach, but now what do we have to assign? We have to assign our junction creation tool. So here we have one junction, right? And then this will be our junction 2, and here this will be our junction 3, this will be our junction 4, and at the outlet we have junction 5. So why we have added this junction? Because if you just want to combine the basin flow with the other basin's flow, then you need a junction, right? That's why we need a junction creation tool. So the thing is that now these are not connected. The subbasin is not connected with junction, and the junction is not connected with the ridge. So the next step is what? We have to connect all these subbasin links and the streams together. So let's see how can we create our link. So if you just expand your subbasin, because all the hydrologic elements are listed there by this time. So see, we have subbasin 1 to 5, we have ridge 1 to 4, and we have junction 1 through 5. But the junction 5, I'm just renaming it. You can right click and then rename it as the outlet, since it is the outlet of this watershed. I'm just giving the name as outlet. Okay, it is outlet. So when you click on this subbasin 1, so see, you can see here the properties of subbasin. You need the area. You have to choose different methods. The canopy method, we have dynamic canopy, graded simple canopy, and simple canopy. So for graded model, you need definitely the graded simple canopy, but for this case, since our model is lumped model and it is for the first model, I'm not going to select any one. And for the surface method, we have the same graded simple surface or simple surface. If your model is graded, you have to select graded simple surface. Otherwise, you have to select simple surface. So I'm not going to select any one of these for this model. And for the loss method, because I have discussed all these things in the tutorial too, we have to select a loss method. There are different loss methods: deficit and constant, exponential, green and amped, right? And the graded version of these methods, and there are SCS method, soil moisture accounting, and I already discussed that if the simulation time is longer for several years, you have to select this soil moisture accounting, or for lumped model, and if you want to just model for a specific storm event, then your model is event-based model. So since I'm going to model the Hurricane Harvey that occurred in 2017, it is at the end of the month August over the Houston, Texas, here in USA. So that's why this model is event-based model. I'll run the model for 1 week. So I'm going to select the SCS curve number. Yes, and then the transformation method, because we will use the depth of precipitation as centimeter or as inches, and then it will convert this depth into discharge or flow rate. That's why we need a transformation method. So I'm selecting here the Clark unit hydrograph. So you can see the theory in the hydrology book for more information. And for the base flow method, I'm not going to select anything, but see, there are several methods: bounded recession, constant monthly, linear reservoir. The linear reservoir method is the most popular method. You can select it, or the recession. In the later models, when I'll set up more complex model than this one, so I'll select all this method and I'll show how to run the model if you select all these things, and how to estimate the parameters for every methods that we are going to select. So I'm not going to select any method for this recession for the base flow. So what I have to do, I have to know the area of this sub-basin. So if you use GIS for preparing this basin boundary, so you can easily calculate your basin boundary, right? So I have already calculated this, and you will see all the information if you click the download link that you can find in the description. Okay, so for connecting this sub basin with the junction 1, so here you can see I'm just selecting sub basin 1, that's why I'm seeing this. So what is the downstream hydrologic element? So at the downstream of sub basin 1 I have junction 1. If I click here and if I just click anywhere, it will be just, see, it is now connected. And if you click on junction 1, so we are seeing the property of junction 1. So which one is located at the downstream of junction 1? If you click here, it is the rich 1, right? You have to select the rich 1. That means now the subbasin 1 is connected with junction 1 and the junction 1 is connected with rich 1. So you have to do this for the rest of the hydrologic elements. So now click on the rich 1. Which one is at the downstream? It is junction 2. Select it, right? And now click on junction 2, and at the downstream of junction 2 we have the rich, right? So this is rich 1, this is rich 2, this is rich 3, and this is rich 4. So the rich 3 is at the downstream of junction 2, right? So if you just click here, this one, you see the most interesting thing, these are not connected, these are separate. If you just put it here, if you put it here, even if you just put it here, no problem. When you just select which one is located at the downstream, what will happen? See, it is automatically connected, right? So you have to do the same thing for the subbasin 2. So the downstream hydrologic element is junction 2. Select junction 2. It is connected. Subbasin 5 or subbasin 3. Which one is located at the downstream? It is junction 3. It is connected. And for subbasin 4, the junction 4 is located at the downstream. It is connected. For subbasin 5, the outlet is located at the downstream. So it is outlet, right? These are connected. And let's connect the other junction and the rich for this side. So the junction 3 is connected with rich 2. It is connected. The rich 2 should be connected with junction 4, this one. It is connected, and junction 4 should be connected with rich 4. It is connected. The rich 4 should be connected with the outlet, right? See, that means all the links are now connected. So the model is now continuous. There is no link that is not connected with other hydrologic elements. Okay, so for the simplicity, I'm just removing the streams here so that you can see clearly. Yeah, right? So the next step is to provide the input data for each of these hydrologic elements, right? So you already have selected the method for subbasin 1, right? Canopy method none, surface method none, the loss method is SES curve number, transformation method is Clark unit hydrograph, and base flow method is none. So I already have the area and the other information. For the area of subbasin, it is 14.2068 square mile. It is there. So if you just click on the loss method here, so it is asking for initial abstraction, in inches, curb number, and what is the impervious area. Impervious area means the percentage of the whole area which is not pervious. So for calculating this impervious area, you need your soil information, you need the land cover information. So I'll show all the steps in the later tutorials so that you can easily calculate all these things using GIS, and how can you download all the informations from different websites. Okay, so for initial obstruction it is 0.5 and the curb number it is 95. The percentage of impervious is 15%, and if you click on the next tab, which is the transformation, it is asking for the time of concentration. You know what is the time of concentration? It is the time required for any drop of rainfall or precipitation from the remote point of any sub-basin, right, to flow to the outlet. That is the time of concentration. And there is storage coefficient. It depends on the soil information. So for this case, the time of concentration is 12 hours and the storage coefficient is 2.28. So we are done for the sub-basin 1. So click on the sub-basin 2, right? So you have to select the same method, curb number and the Clark unit hydrograph, and none for the base flow method. The area for the sub-basin 2 is larger. It is 37.202 square mile, and for the loss method it has initial obstruction 0.5, same for all the sub-basins, and the curb number is 90 and the percentage impervious is 15%. So the transformation, I have the time for the sub-basin as 14.51. The storage coefficient is 0.2. Right, we're done with this sub-basin, and let's do this for sub-basin 3. You have to select the same methods, sales curb number, Clark unit hydrograph, and best flow method as none. The area is 5.748. The loss method is same for the initial obstruction, 80 for curb number, and 10 for the impervious. And what about the transformation? The time of concentration is 5.10 and the storage coefficient is 3.90. And for sub-basin 4, select the same method, SCS, and none for base flow. The area is 4.844 and the loss method is here, initial obstruction 0.5, the curb number is 80, percentage impervious is 15, transformation we have 3.71 and the storage coefficient is 3 hour. For the sub-basin 5, that is draining into the outlet directly, select the method SCS curb number, transformation as Clark unit hydrograph, base flow as none, and then put the value of area, which is 17.80 square mile. Loss method same, initial obstruction is 0.5, the curb number is 80 and the percentage impervious is 15. For the transformation method, we have time of concentration as 9.58 and the storage coefficient is 7.10. So we're done with all the sub-basins. We have already put all this sub-basin information. So the remaining thing is that we have this reach. For reach 1, we click on the reach 1, it will show the properties of reach 1. You see the routing method. For the which one we have to select any routing method that I have discussed in the tutorial 2. So what is a routing? So when the water will be accumulated at the outlet of subbasin 1, so I have to route this water to the downstream side, right? So how can I do this? I have to route this flow. So there are several methods. Since it is hydrologic model, we have to select hydrologic routing method. So lag method is another hydrologic routing. There are kinematic wave, there are modified pulse, Muskingum, Coons, normal Daves, and these are the methods. But for simplicity, we'll use Muskingum method because it has only 2 unknown criteria. And for the loss or gain method, I'm selecting none. And if you click on the routing, it's asking for the K value and the X value. By this time, you know the X value ranges from 0 to 0.5. So you can find this value from the Excel file, right? So now let me show you where you can find. You see, this is rainfall RV XLS. If I open this, you can find it here. The basin model, all the information are here. And for the reach creation, you have all this K and X values for the 4 reaches, right? Okay. So let's open it again. So for the reach 1, the Muskingum K, it is the travel time. That means how much time it will take the water from the outlet of subbasin 1 to the outlet of subbasin 2, right? It depends on the length of the channel, it depends on the slope of the channel and other properties. So I'll show how to calculate this K value and the X. So for any river, we just use the average value ranges from 0.2 to 0.4, and then we can fix this while calibrating the model. So for the reach 1, the K value is 3 hour, and the Muskingum K it is 0.2. For the reach 2, we have to select the same Muskingum method and then click on routing. It will ask for Muskingum K, which is 1, it is, and for X it is 0.4. And for the reach 3, select the same Muskingum method, click on the routing parameter, 2 hour for K and 0.2 for the Muskingum X. And the last one, but it is not the least, reach 4. Choose the Muskingum method, click on routing, 2 for travel time K and 0.2 for the X. See, I can save the model here. So we're done with this. So our basin model is perfect. So we need 2 more model. What is that? The meteorological model. So click on component and just click on meteorologic model manager and click new. You can change the name. I'm not changing here. Just create. So we have meteorological model here. See, if you click here, it is showing this thing. Unit is US customary shortwave. So if you use any evapotranspiration method like Penman Montage method, so you have to provide the information like shortwave, long wave, solar angle, and then the location of your meridian and other things. So I'll show all the information, all the steps in the complex model. So if you are able to run this model, and if you are able to if you are able to calibrate your model, then I'll show you the most complex model. So for this case, I'm not selecting any evapotranspiration module for this case. So I'm selecting only the precipitation hydrograph. and for evapotranspiration it is none, snow melt none, and let's see, replacing missing value. If your precipitation time series has any missing value, so the model will be aborted. But what you have to do, you have to change the set to default. That means if you have any missing information in your precipitation data, the model will just assume that your data value is 0. Then the model will not be aborted, so it will continue to run. So I'm selecting set to default. So if you click on the hydrograph, right, there is nothing because we haven't created any precipitation gauge. So what do we have to do? We have to create a precipitation time series. So again, click on component and then click on time series data manager. If you click on this, see, you can create time series for precipitation, time series for discharge, stays, temperature, radiation, wind speed, air pressure, humidity, and all other things, sunshine hour. So we'll see in the later tutorials when we'll use evapotranspiration module for. But for this case, I'm selecting the precipitation. Click new. It is gauge 1. Okay. Time series. Click here. Just expand it. Click on gauge 1. It is asking for the information. What type of information? Since it is not a graded model, you don't need to provide your latitude or longitude. Just the data source is manual entry. And what is the unit? So for this case I'm using the US customary, that's why it will be incremental inches. And what is the data interval that I have? So let me check the data first. Here, if you click on the rainfall tab, you will see the rainfall. The rainfall started here from the August 25th, right, at first hour. That means 00 hour means it is the middle of the night, 12 a.m. and 1 means it is 1 a.m. and we have the 1 hour data interval, and the data has the limit up to 30th August 2017 up to the 00 hour, that means 12 a.m. and you can see this is the graph of the precipitation. Basically this precipitation is for the hurricane Harvey, right? So in this, the rain column shows the rainfall in inches. So I'm just going to select this rainfall and I'm just copying it. So what is the date? It is 25th of August 2017 and the starting time is 1, right? And the ending time is 30th August 2017 and the ending time is 00 hour. And I'm just changing the time interval. It is 1 hour. And now expand this gauge. So click here. So you have to provide your starting time, that is 25th August 2017. The starting hour is 1 hour and the ending time is 30th August 2017 and the ending time is 00, right? So if you click on the table, it will automatically create the table for you, right? It is there. And if you just click here and if you press Ctrl V, it is there. If you click graph, it will show the graph here. This is the hydrograph. This is our input forcing. It is the precipitation for Hurricane Harvey that occurred over the Houston area. It was like devastation, huge flooding was there. So now click on this specified hydrograph. Did you see anything? No. Click on the MET model. It is there. So now we have to click on the basin. See? So basin model, it is there, includes sub basins. It is now no. If you click on yes, then let's see what just happened. Now click on the specified hydrograph. See, it included all the 5 sub-basins. So if you click here, yeah, you have to specify the gauge 1 for sub-basin 1. If you have different gauges for different sub-basins, you have to create different time series. So I will also show this type of thing in the later tutorials. So for this case, I'm assuming that since the total basin area, the model area is not too large, that's why I can use the one precipitation gauge for every sub-basins, assuming that the precipitation is uniform over this basin. So I'm selecting the same gauge for all the sub-watershed, right? So now my model is almost ready. I have my sub-basin. I have already provided all the sub-basin parameters, and I have already created my time series, and I have the MET model. Now, based on this input data, we have to create another component, which is the control specification, right? It is the controller specification where we have to specify your simulation time, starting time, date, and ending date and time. You can rename it, or I'm just keeping it as it is. So it is there. Control specification. Click here, click on control. It is asking for the date and time. Since I have the precipitation data from 25th of August, so I'm giving the same date, 25th August 2017, and it is now not 00, basically it is 1 hour, and then the ending time is 30 August 2017, ending time is 00, right? So time interval, so you can easily run your model for 5 minutes, 10 minutes, anytime you want, right? You can also run your model for 1 hour interval. So let's see, I have the given interval. You cannot select any other interval other than this. So from 1 minute to 1 day, you can select any time. If you select 1 minute, your model will take time. If you select the longer time period, then it will take less time. So for this case, I'm selecting 15 minutes because I have 1 hour precipitation data. So 15 minutes is okay, right? So this is my controller specification, and I'm just setting the model. Now, if you want to run the model, what do you have to do? You have to click on compute, and let's see, the tutorial 3, there is nothing. Now just click this button here, compute, and then simulation run manager. Click new. So I'm just creating a simulation module, right? So this is run 1, or I can just rename it as test run. You can create different combination of runs. So for test run, clicking next, it is asking for sub-basin. So since I have only one sub-basin, I'm selecting one. If you have different sub-basins, and if you want to create different combination of runs, you can select different one. So for this case, since I have only one, I'm selecting this one, and it is also asking for the MET model. If you have different MET model, you can select the different one, and you can create different combinations of your run, right? So I'm selecting the control 1 because my controller specification already specified from August 25th to August 30, right? Okay, finished. So now see, if you have completed this step, you will have this thing activated. So now if you want to run it, you can right click here and click on compute, or it is also there. You can click on this bomb button. If you click here, it will start running. So I'm just clicking. See, it is checking, and then since it is only for 5 days, the run is completed because I have the 16 GB of RAM. The laptop is pretty fast. That's why it takes a fraction of seconds for running this model. So if your model simulation is completed successfully, you will see here a close button, and you can also see here finished computing simulation run. So I'm just closing this, and for watching your result, click on this result tab and then the simulation and click the test run. So you can see the global summary. If you click on the global summary, it will just show you the list of all the hydrologic elements here, and all the areas are there. You can see only the peak discharge in CFS and the time of peak discharge for every hydrologic elements, and you can see also the volume in inches. I'm closing it, and if you click on Sub Basin 1, right, you can see the graph of what? Graph of the runoff at the outlet of Sub Basin 1 here. See? So the upper part of the graph is showing the hydrograph, and the lower one is showing the runoff at the outlet of Sub Basin 1. So see, the peak flow is around 9,000 CFS, right? So at the outlet of Sub Basin 2, let's see what happens. Click on Sub Basin 2. See, it is higher than this. It is more than 20,000. That means the flow has been accumulated at the outlet of Sub Basin 2. It is a combination of flow Sub Basin 1 and Sub Basin 2. You can also click on the Sub Basin 3. You will see another curve. Since the basin area is very low, it is like 3,500 CFS, the peak discharge. For Sub Basin 4, you can see it is almost same. And what will happen at the outlet of the all sub basins, that means the outlet. So click on outlet, you can see several graphs. See? So this one, so if you click on result, click on graph properties, you can see all the hydrologic elements that are draining into the outlet are listed here. You can delete all other things. The risk 4 is draining into the outlet. I'm deleting it, right? The Sub Basin 5 is directly draining into the outlet. I'm removing it. And also the risk 3 is also draining into the outlet. We can also change the color. We can change the color also here. You can also change the type or the width of the line. You click on apply, right? It will be there. You can just refresh it, so it is there. So this is how you can run HEC HMS model, and you can set up any HEC HMS model from the beginning. So this is the most simplest model that I have shown you today, and if you are interested in this modeling software, you can download this practice basin boundary and the basin information, and you can practice this model first, and then in the later videos I'll show how to download the observed stream flow data from the website, and then how to create time series and how to calibrate model. And if you have any difficulties while running this model, or if you have any trouble with running this model, you can just let me know. You can put your comments, or you can just directly ask me question if you have any opportunity. So I'll be happy to answer all of your questions. But for running this model, so it looks like a very simple model, but when I'll show you a more complex model, then you need to know the previous steps. That's why you have to cover all these things, and you can use this type of model for your research. So I'm just ending my tutorial here for today, and I will upload different videos later on. When I'll make another video, I'll let you know. So until then, thank you very much.